Hello, my name is Fred Hunt. Today I am showing a demo of Polarith, an AI AI package that you can download on the Unity Asset Store for free. Just go to the Asset Store and type in Polarith. It'll be right there for you. They have a free and paid version, but today I'll be demoing off the free version rather than the pro version. So first we'll start with one of the simplest um, mechanics, which is arriving at a target. You see the AI will move, and you notice that it slowed down just before it actually reached the inner circle, which is its actual stopping distance. So if we look at our AI's arrive script, he has our inner and outer radius. The inner radius affects how close he gets before he actually stops. The outer radius, on the other hand, instead affects when he will start to slow down as he approaches. So as you notice, he will, with a 10, he starts slowing down a lot towards the end because he's trying to slowly brake until he gets to the object, rather than if this was like a 3 and I backed him off. He's going to move in full speed until he gets to that 3, and then he'll slow down a little bit there just at the end. The next uh, simple behavior is following. It will, this will pretty much follow this dot endlessly, and it doesn't actually pay attention to how close it is to the dot. Like with the arrive script, you notice that once it got to a certain distance, it'll slow down, and then you have a distance that it'll stop so that it doesn't actually collide with your object. The follow will instead just keep chasing until it's there, and it'll keep chasing even after it's there. If I was to put in a cube here and then have my AI instead follow the cube, you'll notice that it will go inside of the cube and continue to move around. I can move the cube somewhere else and it'll go over there, but it won't try and not go inside the cube. It will collide with it and do all that. But the arrive will prevent that if you use that instead. So next we'll move to fleeing. This is a very simple, it just finds the vector that is away from the object that is moving towards, or the object that is told to avoid, and will move the opposite direction. So here, once it's within 3 units, it'll just flip and go away from it. It is just 100% the opposite vector. No other things. It's just trying to stay away from the object. It doesn't do any prediction or anything like that. So now instead, when it's within 1 unit, it'll flip and go the opposite direction. Because it's just finding the vector that is away from the object directly. Evade, on the other hand, and I added a couple extra um, AI to follow. So evade will predict where the AI is going to be and try and avoid that location. So rather than just moving directly away from it, so as you see, as it's moving up directly away, it would move back down this way. But instead, it predicts where it will be and will try and steer around that, while also this blue agent has a target location that is up above it, so it's trying to get there. And so that is why it's not just going straight away from all of the things that are chasing it. If I was to up his outer radius, so instead of a 2, let's make it an 8, as he approaches these, he'll make his decision that he needs to move away from them much sooner because they're too close. Once they go within an 8, they're too close, and he'll move away from them. And if I can change prediction time to make it so that he will instead, because he's moving away from really where the AI is going to be at a certain time. So if I up the prediction time, it will affect where he's trying to avoid. Or the avoid will, this is in tandem with the follow script to get to the circle, will detect danger and try and go away from it. The plane bend parameter will kind of affect how harshly it will steer away from it. So at a 0, it'll just, straight out away. But if you go up to 25 or 45, that's how many degrees away it will, suddenly change. But that is from already 90 degrees from it at 0. Um, so a higher number will result in a higher, you know, sudden turn away from the object that it is trying to avoid. We also have the reduction behavior, which allows the AI to, rather than just avoiding trouble that's in front of it, to brake for passing trouble. So it's useful for things like traffic. If there's a car coming across in front of you, you want your vehicle to brake and not just run into it. As you see, the blue and red agent are both using the reduction uh, behavior, and so the red one will also brake when the blue one slows down in front of it, as you see, to also avoid colliding with it. So, like I said, very good for traffic. And then seeking is similar to follow. It will find where the next closest item is of that type and will go and collect it. So to just keep trying to find the next one. And then the wander mechanic, it allows your AI to just walk around with no real goal. It's just for farm animals or anything like that that you want to move around unintelligently. Um, there's a couple parameters as well here that you can change, like the max time to make a new deviation. So it'll decide a new direction between 0 and 3 seconds now. So as you see, he chose a higher deviation time, so he just went that way for a long time. Now he's going straight for a really long time, or kind of. So now those are really short deviations, so he's deciding quickly to go back and forth between those directions. He's actually, there we go. He was choosing those really quickly. Here we have the angle, so I can change, the minimum or maximum angle that he can choose to turn. This right now between 0 and 25, so he'll only ever at max go out to 25 degrees in any direction. Um, but these scripts also all work in tandem really well. So if I have this AI wandering here, I can also, if I want him to stay on the screen permanently, which he happens to have so far, but there's no rule telling him to, I could add avoid or flee objects for him to avoid or flee around the edge of the screen. That way, if he got too close to them, he would instead turn and walk back towards the middle of the screen and then continue after he gets too close. Um, as you've seen, some of the other scripts use the follow to, have the object going in a direction and then do things such as avoid, stuff like that. So all of these can work in tandem to do really cool things. The orbit allows a AI to kind of just go around in a circle around a point. You see here we have one of the AI also using the avoid script to not hit the other object. And the parameters that you have to interact with for the orbit is the radius that it goes. So it can go like 5 units from the target, which is in the middle, or 3, which was the default. Um, and there's deviation, so how far it's allowed to kind of go from the circle, but it has no reason to go away from the circle, so it won't change that. The AI that is going around whenever he has to avoid something, that will take over, and so he will stop orbiting until danger is out of the way. Once danger is out of the way, he'll go back to orbiting as best as he can. There's also pursue, which is a very useful mechanic in games. This allows, rather than just directly following the AI or the target, it will instead try and predict where it will be and go there instead. So parameters that we can interact with on it are, how far it predicts out ahead of it. So if I make this a smaller time, you see he was kind of ahead of it. If I have him only predict 1 second ahead, he'll choose a closer point, and you'll notice that he's actually on top of him here this time when he goes. Or if I make it a bigger number, as he's chasing the target, he'll pick a further out point, and so now he's going to try and chase that instead. So uh, it's useful for predicting and trying to cut off targets rather than directly getting to them. And to show some real in-use examples, there is this little fish simulation where the blue fish are just trying to wander around near the center of the screen, so they have a gravity that pulls them towards the middle of the screen. But they're also avoiding the fish. So once the big red fish, so once the big red fish gets nearby, they will avoid, try and go out away from it. But they're also trying to get to the center of the screen. So eventually they will avoid in a way that they'll get around it and they'll come back to the middle of the screen and they'll hang out there until something else comes by to harass them. And an example of the traffic. So here you'll see these still work in 3D. You'll notice that the cars on the right here are using the reduction script to avoid the cars that are coming across and also avoid each other. So then once there's no cars, you'll notice that they will just go ahead and go across. There will be more cars here, so they'll keep coming. But you'll notice once more cars actually spawn over here, that when cars are in their path, they will hit the brakes to not hit them. It doesn't make for the smoothest of traffic because they don't actually make it to the intersection before they decide to brake. They'll just brake if anything's ever in their collision path. But it does make for it works. They do not collide. I let this run for about 30 minutes just watching. I was like, they gotta collide eventually, but they actually do a really good job of not hitting each other at all at any point. I figured one of the cars would end up like in the road and hitting the brakes at the wrong time and being in the way, but it actually never happened. They seem to actually know when they can cross without a vehicle hitting them. And if there is a vehicle coming fast enough, it just won't go. Um, so once again, this is Polarith, a AI package you can download in the Unity Asset Store 100% for free. If you want to get the Pro version, it's $95. But all of this that I showed you comes in the free version, so it's up to you. Thank you.